So, let's be efficient with our time. All right.
Efficiency.
Isn't it? So, make a scatter diagram. Can we do that by hand? I mean, we could do it on a calculator. Is it hard to do by hand?
Yes.
Yeah.
Much harder.
Must know.
Yeah, it's not terrible. So you can use your calculator if you want. I think for the sake of being fast for a moment, I'm just going to.
Are we drawing?
wait,
Whoa.
You can do whichever way.
Are you just doing what's like going through the calculator right now?
Yeah. So you can put it in the calculator if you want. Put it up here. I'll just go ahead and do it. 0.5.
Are we drawing for each other?
A rough sketch is fine. On any homework questions that ask you for a scatter plot, as long as you have enough that I can see what it looked like to know you were putting or had the right information, that's fine. Okay, so everyone remembers how to do this on the calculator? Or it was a small set, so I did by hand as well.
Zoom
And does your graph look like mine? Basically. Okay. So, if I asked you to find a linear equation by selecting 2 points. So, I'm not asking you to find what the calculator says. I want you to pick 2 points on this graph to do it. So we would have to pick points that look like they would give us a good model, right? We don't just necessarily go with the first and the last. If I were using the first and last to write an equation, does that really follow my data trend? No. You can see all those other points are above it. So which 2 do you think would be decent? What about
The second and the last.
the second one and the last one?
2
So,
and 3.
I don't know what that was.
Hello?
I think it was the.
Just hit the door. Okay, that makes sound stupid. No.
I've done it too. It's okay. And 6.
Oh my gosh.
What did we say? 2.2? Is that the one you want to use? Okay. Now, if I pick 2 different points, would I get the same line? No. But I'm trying to make a point here. So if I'm making 2 points, we know we have to have our slope, y2 minus y1 over x2 minus x1.
Oh, I remember.
So I get a slope of negative 0.875. And then plug into y equals mx plus b.
Oh.
What? This is where we give up writing the equation of a line?
Yeah.
No. I'm going to go call Mrs. Keller in here and see what she has to say about that.
I was 5.7 for.
I thought we retired.
As soon as we
Why?
somehow.
Why?
I just never remember us doing stuff in college. What is BC for again?
What's
I know we already did this.
That's 6.
Oh.
what?
Okay.
Would that be possible? I thought that was B. Wait, it is B.
I heard him ask
Yeah,
you about
that is
negatives.
Is that a B or a 6?
That's B.
B.
Look at her 6 and then look at the B. They're totally different.
I was right. No.
No.
Just because they're trying to.
Bradley, they not
What is
really.
B equal?
No. Her 6 is like if you were slumping down in the couch.
What is-
Okay,
what is B?
so
Yeah, no.
equation of a line. You have to find slope, change in y over change in x. And then I picked my first point in my slope, plugged into y equals mx plus b, and I found my b. Okay, if I were graphing that line, we did it between these 2 points. Of course, we could extend the line on a little bit further. Does that seem like a decent line for our data? Sure. Okay, let's use it to predict. If I said x was 3 and I wanted to use my line, negative 0.875 times 3 plus 7.45. What did we get?
4.8.
Okay. Does that look fairly consistent with our data? Sure. Now, is this perfect? No, because I just picked 2 points. If I had used the 2.2, the 6, or sorry, 1.9, whichever one I did, it would change my line slightly. So this is the idea of a line of best fit. I remember when you first learned these, like in algebra, you would, where's all that smoke? When you first did this in algebra, you would take your ruler and try to draw a line that had about the same number of points above and below, and estimate it from there. But it wasn't a precise thing, right? We couldn't be sure. So now we are going to be able to find it exactly. One calculation we are going to do with this is what's called the residual. We know, we predicted, based on our equation, that we would get 4.825, right? But when I looked, my actual data, when I put in 3, I got 5.2. So there was a difference between them. So the residual is the difference between the observed y value and the predicted y value. You guys have your formula sheets where we keep going for everything. So we are in chapter 4 now. And it's the first bullet on the second column. Observed y minus the predicted y gives us our residual. So my observed y, observed is what really happened. So when x is 3, what did we really get out from the data? .2. Predicted is what we would guess from our line. So when we used our line, we got 4.825. Okay, so residual, you subtract this.
So the observable is already going to be in that.
What happened in the table is observed. So our residual is 0.375. If you have a good line, that residual should be pretty small because what you predicted it to be from your equation should be pretty close to what it was in real life. Obviously, the further apart those are, the bigger residuals, the more error there is in using our line to predict our data. So the idea of the perfect line, or the best line, is to make all of those residual values as small as possible. We want as little error as possible. So that is the least squares regression line. You usually see that with a y hat. That just tells us it's the line to match our data, not necessarily a one that was given to us. So the formula to calculate it, a line, y equals mx plus b. Okay, the notation is a little weird on here. They use m or b sub 1 for your slope. And it's calculated with things that we've already found. R times the standard deviation of y divided by the standard deviation of x. What's R? Where have we seen that? The linear correlation coefficient that we were finding on our calculator last time? Yeah, we got that when it actually calculated the line for us. Then s sub y and s sub x, that's our standard deviations. The y-intercept, it's y bar, what's that mean? The mean of y minus b sub 1 is our slope times the mean in x. Alright, we are pretty much going to primarily do this on the calculator, but I want you to be able to kind of see these formulas and understand what they're telling you. So let's find the least squares regression line. Do you guys want me to show you one by hand, or do you just want to do it on the calculator?
Why do they use the weird, why don't they just use the normal M instead of the
Because they want you to understand where M is coming from. It's just their notation. Okay, so if I'm doing this on my calculator, enter your data into L1 and L2. Remember, these are ordered pairs, so order does matter in that. And then, what did we go to get our linear correlation before?
Y.
It's
Stat calculate number 4, the linear regression. Your x should be your L1. Your y should be your L2. That's all we have here. And this is all of our information. Does everyone have an R value popping up on their calculator? Remember, if you didn't, it was because your diagnostic was off. Eventually we'll get them all turned on, but every time the memory resets, it defaults to off. So
We want
you want it on.
Whenever we put calculators back, you want to turn it off.
All we need is a regression line, and we really have it. Your calculator does all these calculations for you. We don't have to do it by hand. So the A represents our slope. So -2.1667 x plus our y-intercept is our b, 18.6667. The only thing that I would like for you to do is, instead of just saying y, how do I show that that is my regression line?
The hat.
With the hat on. Okay, that just means it's the regression line. That little symbol across the top.
You give me just.
This little symbol over the top just tells you it's a regression line. And it's on your formula sheet if you forget it. Okay. One thing that I want to caution you on. In a lot of situations, we are going to look at it and try to make sense of what the slope and y-intercept mean. Not possible here, because do you even know what x and y were? No. But do you think this line would be a good fit if I said x was 70? No. Why? My x's are super small. They were only things between 1 and 7. So is this line probably still going to be accurate at 70? No. Same thing if all my values were something between 50 and 80. Do you think it would be a good model when x was 0? No. So it's really only a good model if your x's are similar to the points that were used to create it. If it's not, we just sometimes you'll see outside the scope of the model. Just means it's a really extreme point. The line may not necessarily be accurate here because that x was so different than the x values we used. All right, so let's look at another one. I want to find the least squares regression line. So everybody do this. Enter your data to get your line. So our regression line, our y hat, equals our slope, 3.1661x, plus our y-intercept, so minus 55.7966. There's my regression. I could ask you to draw it on the scatter plot just to verify that it's a good fit. Again, I'm having you do this on a calculator, so I'm not asking you to do it by hand. But if you go back to your calculator and go to your y equals, and enter this equation. You have to have your scatter plot turned on. And if you zoom 9, then we see our scatter plot and it draws the line on it for us. So we can see, is that a pretty good line for our moment?
How'd you do that? Sorry, I was writing other stuff.
It's okay. Alright, so go to your y equals. Just your x variable. So we type in.
So use all of this.
Yep.
That equation that we just got. No, you keep that line. So you do x minus 35 minus 7.66.
And you just say 9.
It's starting and it's crashing.
What'd you do? I feel like it's probably not good.
It's probably Selby. Selby's making the calculator mad.
There you go.
It's just a
All right. Did everybody get that?
I don't even know why.
No.
So that's it's
What?
that slide of-
This is how I feel this is how I felt last year during class. I mean, I don't know what it is, but this hit me today.
All right. Predict. So part C, on the homework, if I asked you to do that, just draw me a rough sketch what it looks like so I know you did look at it. Predict the distance a golf ball will travel when hit with a club head speed of 103 miles per hour. If you look at your table, that is what we used for our x. The distance was our y. So all I'm asking you to do is plug in 103 for your x. We get a prediction of 270.3. What would my units be? Yards. And I know that from the table. It told me that y was in yards. Just guessing? Uh-huh. Okay, determine the residual. You're looking at your formula sheet. Residual is observed minus predicted. Did we actually have a value when the x was 103? What was our observed y? 274. Minus predicted is what our equation gave us. So if I subtract those, we get 3.7 yards. So that's the difference in what actually happened versus what our equation would have predicted. Okay, last question of the day. Interpret the slope and the y-intercept. When I ask you to interpret, I'm asking you to write a sentence. You have to use your numbers. You have to use units in there. Okay, so my slope of this equation was 3.1661, right? Think back to your algebra days. Slope is change in y over change in x. What are the units on y? Well, just in the context of this problem. Yards per mile per hour. Okay, so what does it say? It's a positive. So the ball will travel 3.1661 yards for every mile per hour swing. That would work. Couldn't come up with what I was trying to say. Or if you increase your swing by 1 mile per hour, how much further would your ball travel? 3.1661 yards. Okay, there's not just one correct sentence. But for the slope, it's
You're a little behind.
Yeah, I didn't. So not the
Good.
Back on Brady too.
no, my y-intercept. What is a y-intercept in general?
This where it intersects.
It's like our starting point. It's saying if you hit that ball with 0 miles per hour, what would the distance traveled be? 0. So does it make sense on here that's a negative 55? No. There are situations where your y-intercept may not make sense. Why would that y-intercept not? It can't go backwards, right?
You don't hit the ball.
You hit the trees and
Yeah.
I'm pretty bad.
I
So
know
you would
that.
have to hit it for it to go backwards. You were just hitting it the wrong direction. So, why is that then? Why did we have an equation where the y-intercept really doesn't make sense? Okay, look at the x's that we use to write this equation. Is 0 anywhere close to those numbers? No, that's a situation where it's outside the scope of the model.
It's
This
probably-
line works for things close to 100 miles per hour. It doesn't make sense in the context of the 0. It's outside the scope of the model.
Do you have to pick the middle point every single time, or would it be the same numbers if you picked like 100 and 257?
Like for your
Like what you
residual, it will vary.
It's a
So I only did the
The
residual
answers will be
because,
different, like,
yes.
if I,
But we
Yes,
only
I
did
only did that because I wanted the residual for part C when my x was 1. So, I'm just going to say the y-intercept here is outside the scope of the model.
It's because it's a curved line, so when you're hitting it that slow, it's a much different.
Right. You would need a different
Every mile per
equation
hour-
to model
every mile
something
per hour
like that.
you hit the ball, that's a much bigger impact, I guess.
So, you can always interpret slope. Sometimes you can interpret the y-intercept, but it has to make sense. Okay, if I were measuring how tall something was growing, would a negative height make sense? No. But if you were measuring, like, let's say we were measuring how tall something was growing and we had a y-intercept of 10, what would that tell me?
bigger 10.
It started, the starting height was 10 inches or whatever. When the time was 0, it started at 10 and then it grew from there. So you kind of have to pay attention to your problems to know if that's possible. So, I want to give you guys time to work in class so you can ask questions if you're having any issues. You do not have to do any of these by hand. Regardless of what the book directions say, you can find them on your calculator. Okay? On number 8, it's like parts A through H. You're only doing part A, part D, and part E.
Thank God.
So we're like the second month of school.